Hello. Today we're going to be talking about dilution. Sometimes, science words are interesting because you kind of know what they mean, but then they're really hard to define for people. So if I asked you between the difference between dilute and concentrated, you may not be able to tell me. But if I had a glass of iced tea that was really pale and a glass of iced tea that was really dark, and I asked you which one is more concentrated, I think everyone would say that the dark glass of iced tea. So what is dilution here? So dilution is the process of decreasing the concentration of a solute in a solvent. Usually you do this just by adding more of the solvent. So most of the times that's going to be water. So you're just going to add more water to make it more dilute. So if you look here, this is a concentrated solution here. So you've got 7 molecules in 200 milliliters of water, and this one we just added more water to it, but we still have the same 7 molecules in there, but now it's in 400 milliliters of water. So this one, the one I circled, is the concentrated one, whereas this one is the diluted one. Another image of this is color. We can use color often to represent concentration or dilution. So as the colors become more vibrant, as we move to the right in this little picture here, you're getting more concentrated and it's getting a darker, just a darker color, more saturated. That's what I was looking for. And then as we move the other way, that's going to be more diluted, very pale in color. Okay, so how you get to these diluted parts here, if you say you started here and we want to get to dilute, you're just going to add solvent or add water to that. Okay, so we're going to approach these mathematically here. So the question is, calculate the final, or the statement, directive is calculate the final concentration when 75.0 milliliters of water is added to 25 milliliters of an 8 molar HCl solution. Okay, so you've got your solution here. In this, I shouldn't have done that. Hold on. Clear pen markings. Okay, hold on. I'm going to make it. Okay, so you've got 25 milliliters here, right? Oops. So 25 mils, and it's 8 molar. So that's 8 moles per liter. To that, you are going to add 75 milliliters of water to it. So you're diluting it, right? But so what you have to remember here is that there's a certain amount of molecules that exist in here. I'm just going to put 3 in here, which is not accurate by any stretch of the imagination, but let's just imagine there's 3 molecules. If you add more water in there, there's still only 3 molecules of solute. Right? So the solute molecules don't change even when you're adding more solvent. This would be the solvent here. So we can look at this and we can say, okay, well, I have a volume and I have a molarity. So if you've got a volume and a molarity, right away, hopefully your brain tells you, oh, okay, I've got 2 things. I can calculate moles. So I'm going to calculate moles, and that moles is not going to change because you're not taking out any of the solvent. So it's moles of solvent, right? Or solute, I should say. Sorry. And so the only thing you're changing is the volume of the overall solution. Okay, so let's look how this works mathematically. Okay, so my formula then, actually, let's just do this. So the molarity we know of the solution is 8.00. The volume, I said 25 milliliters, so I'm going to convert that to liters right away. And then the moles is what you're looking for. So your formula, molarity equals moles per liter. So if I'm solving for moles, that's going to be molarity times liters. So 8 multiplied by 0.025 is going to give me 0.200 moles. So I know that I've got 0.200 moles of solute. Now, that solute doesn't change. It is not going anywhere. You are just adding more water. So now, if the question is asking me, what is the final concentration? So after you add that water. So the molarity is what you're looking for. The liters now, instead of having the 25 milliliters, the liters now is going to be the 25 plus 75. So this is 0.25 plus 0.075. And then the moles hasn't changed. You're going to just take it from here is 0.200 moles. So finding the final molarity then, moles per liter, is just going to be 0.200 divided by 0.025 and 0.075 is going to be 0.1. And you're going to get an answer of 2.00 moles per liter. Okay, now, let's just check our sig figs. Is that right? Yeah, that's good. Okay, so this kind of is long, and so luckily there's a shortcut. So I'm going to prove the shortcut to you first. So we have initial condition. So this is all for dilution. So when you're trying to dilute something. And then we have final over here. So initially you've got a solution. So let's give these the 1 conditions. So molarity 1 is going to be equal to the moles of solute 1 divided by the liters of the first solution. And over here, the final ones, we're going to call them 2. It's going to be moles 2 divided by liters 2. So this is just our molarity concentration, or sorry, our molarity formula, which hopefully you know by now. And so what we know in these two things, before I do that, let's rearrange our formulas to solve for moles. So if I'm looking for moles here, it's going to be M1L1. Moles 2 over here is going to be M2L2. Now, what do we know about solutions like this? And if we go back to the other slide here, we knew that the moles doesn't change. So the moles of solute is constant. No matter how much extra solvent you add to it, the moles of the solute does not change. So here, this means that we can say the moles 1 is equal to moles 2. And because of that, I can now say if hold on, let me just do this. If moles 1 is equal to M1L1 and moles 2 is equal to M2L2, and I know that moles 1 is equal to moles 2, that means that I can now say that M1L1 is equal to M2L2. And so our dilution formula, this is a shortcut that you can use, is M1L1 is equal to M2L2. You'll see other letters sometimes. So sometimes you'll have C1V1 equals C2V2. I actually think that might have been what I was taught when I was in high school. C being concentration, V being volume. It doesn't matter. The formula is the same whether whatever letters you use. So you are going to need this. So make sure you memorize this. Incidentally, when I worked in, I used to work in a lab for 5 years. I don't know if I told you guys about that. Anyways, you make solutions constantly in a lab. So when you're doing lab work. So this unit is actually probably the chemistry knowledge that I use the most when I worked in a lab. Kind of interesting, you know, I had a whole degree in chemistry, and yet it was my grade 11 chemistry course that I think I probably used the most. Okay, so we're going to use this formula here and do some problems. All right, so calculate the volume of stock 18.0 molar H2SO4 that would be required to make 300.0 milliliters of 3 molar solution. So this is very typical of what you would see in a lab, or what you would do in a lab. So this is what, here is what a stock bottle looks like, and if we were in class, I'd pull one out for you. They're large, they're 4-liter jugs, glass jars usually, And they're very concentrated, and that's how you buy it from the supplier. And you buy it like that just for practicality. And then you use this stock, which is fairly concentrated, and then you dilute it down for your purposes. So this whole 18 molar thing, that's really concentrated. In most lab work, you would never use something that concentrated. It wouldn't be necessary. So you would always want to be diluting it down. So that said, let's figure out our variables. Always a good idea. Variable list, right? So M1, L1, M2, L2. Now, one of the hardest things people find about this is figuring out the variables, like how to read the question properly. So calculate the volume of stock 18 molar. So right away, I know that I've got stock 18 molar, so 18.0 molar, and then it says calculate the volume. So that's what I'm looking for. I want to make a solution with these conditions. So I want to make 3.00 molar, and I want to do 300 milliliters of that, and I'm going to convert that right away to liters. So now I've got 3 variables, a 4th unknown, so I can solve for that. So M1, L1 equals M2, L2. I'm looking for L1, so L1 is going to be equal to M2, L2 divided by M1. Sub in my values, and so I've got 3 times 0.3 all divided by 18. And for an answer, I end up getting 0.05. I need another sig fig there. I need 3 sig figs, so your answer is going to be 0.0500 liters. Oh, sorry, my screen is running out here. I'm going to write it here. 0.0500 liters. You will often see the answers for these questions in milliliters, and it's simply a convenience sake. When you're working in a lab, 0.0500 liters is not as meaningful as saying it's going to be 50.0 mils, right? So either one, these are the same things. If you answer in liters, that's great. Don't worry about it. Keep it like that. But just know that your answer keys are often going to be in milliliters because that's what you would use when you were working in a lab. Okay, let's do another example. So what volume of water must be added to 150 milliliters of a 5 molar solution NaOH to make 2 molars solution? Okay, so M1, L1, again, M2, L2. Okay, so my first condition there, so I've got 150 milliliters of a 5 molar solution. So that's going to be my initial conditions here. So 5.00 molar, and I've got 0.150 liters here. The question, what volume of water do we need to make? Sorry, hold on. Oh, sorry. I said that wrong. I'm sorry. Okay, so we start with this solution, and this solution here, and I want to find out how much water I need to add to that to make this. And so my secondary conditions are going to be 2.00 molar here, and so I need to figure out what is the volume of my final solution going to be when I start out with this. So I start out with this solution here, and I want to dilute it to the secondary condition here, the 2 molar. Okay, I'm going to switch colors just because I want to. So we've got M1, L1 equals M2, L2. I'm solving for L2. So L2 is going to be equal to M1, L1 over M2. And then we just sub in our values again. So 5.00 times 0.150 all divided by 2.00. And I get an answer of 0.3 375, oops, that's supposed to be a 7, 375 liters, which is 375 milliliters. Now, if we were in class right now, I would say, okay, who got that answer? And you would all have gotten that answer. And then I would say, you're all wrong. Why are you all wrong? So I want you to read the question again. So what volume of water must be added? That's the key to make the sodium hydroxide solution of 2 molar. So what you solved for, this is here, what you solved for was the volume of the second solution, the diluted solution, which you need. But the question was asking, how much water do you need to add to this to make this? So how do you figure that out? Yeah, you're just going to subtract them. So you need to end up making 0.375 liters, but you start out with 150 milliliters. And so if we subtract those two from each other, you end up with 0.225 liters. So to solve this question, you would then say 0.225 liters of water must be added. And that's that. So that question is a little different. It's kind of the little trick that you might run into. So try not to get confused by that. And just always read the questions really, really carefully for these. There's nothing difficult about this. I mean, it's a 4-variable equation, right? It's not really that hard. The difficult part is just interpreting the question properly. Okay, so your assignment for this is exercise 47. The answers are at the bottom of the assignment, so make sure you check them there. Okay, and I guess that's it for this lesson. Yeah, email, message me.